Hi there, myself Madhav Jha. I welcome you to CodeChef and let's have a look at this question.
The problem is deleting array again. The problem difficulty is easy and there are no prerequisites. Let's have a read at the problem. You had an array A of size n and a cost array C of size n. You will do exactly n operations of the following type. First, choose I such that I is greater than equal to 1 and less than equal to length of the array A and delete the element AI from the array A. The associated cost with this operation is AI into Ci. After each operation, the remaining parts of the A are concatenated and reindexed from A to length of 1 to length of A. Note that C is not modified. So when we have this array A that has the elements A1, A2, A3 till AN, and similarly we also have a cost array C1, C2, C3 till Cn. Now if we were to delete A2, the cost associated will be A2 into C2. But once this is deleted, we will reindex and concatenate the remaining A array. In that case, all the elements after A2 will shift by 1. So A3, A4 till AN would be here. And now the cost associated with A3 is C2. Similarly, we can perform this operation and we need to find out what is the minimum total cost needed to perform n operations and thus deleting array A. So for the input format, we have t test cases and for each test case, we are given 3 lines. The first line contains the integer n, that is size of the array. The second line contains n spaced integers and the array A, that is A1, A2 till AN. And similarly, on the third line we have the array C, that has n integers C1, C2 till Cn. For the output, on a single line we have to output the minimum cost to delete the array A. As for the constraints, number of test cases will go from 1 to 100, value of n and the value of elements itself will also go from 1 to 100. Let's see some sample inputs. So for the very first sample input, the value of n is 2. The array associated are A is 4 and 2 and the value of C is 2 and 1. We'll delete first 2. So if we delete 2, the cost will be 2 into 1, that is 2. Then we delete 4. The cost will be 4 into 2, that is 8. So a total of 10, and that is the solution here. For the second sample input, again, we are given n as 2. But this time, the value of array A is equal to 4 and 2, same as before, but C differs as 1 and 2. Now in this case, first we will delete the first element, that is 4. The cost in this case is 4 times 1, that is 4. Now once this is deleted, everything will concatenate and get reindexed. So now 2 will shift here. So now our array A will transform into 2 and empty here. Now again, if we delete 2, the cost is again 2 times 1, giving us 6. And this is the total minimum cost required to delete the complete array. Let's see how we can approach the solution. As we have seen in our array A, we need to delete everything A1, A2, A3 till AN. All of these elements have to be used. So our cost will include all the elements in our array A. But that is not the case with our arrays C. In C, we can choose which one to use. And the way that we can choose to do so is that once we delete something from array A, it is deleted and all the elements to the right shift 1 to the left. With this, if we find an element in the left in C that is a small number, relatively smaller from the elements to its right, we can use that to delete all the numbers to its right. So imagine this. If C1 is the smallest number in C, what we can do is we can keep on deleting the first element from A always. The moment we delete the first element, rest of the elements again shift to left and we again have an element here that we can delete. So what we can do is, starting from the left, we will check what is the smallest element. For the first element, there is nothing that we can do. A1 will have to take C1, so C1 will stay. But for the next element, we will check whether it is better to use C2 or C1. Why we can decide to use C1 is that once A1 is deleted, A2 will again shift to left and it can be deleted using C1. Therefore, this will become minimum of C1, C2. We can define it as Ci is always going to be equal to minimum of Ci, Ci minus 1. We'll do this from left to right, and then for each corresponding element in A, we will find what is the minimum cost of C that you can use to delete this. With this, we will sum all of them up and we'll get the solution to delete the array A with minimum cost. Let's see how we can implement the solution in C++. So for each test case, we call the function solve. In solve, we take the input of n, then we take the input of our two arrays, A and C. Once we have that, we initialize our answer, that is the total cost of deleting the array A, as A0 multiplied by C0. As we have seen in the approach, there is no other element that we can use for the very first element. But after this, we have a choice to choose the current cost C or the previous cost C. So whichever is the minimum, we choose that as our current value of C of I, and then we delete that then we delete the ith element from A. So our cost becomes Ai into Ci for that ith element. We keep on doing this for all the indices, and at the end, we have the minimum cost required to completely delete all the elements from A. At the end, we print this, and as you can see, I have AC in my C++ implementation. Let's see how we can implement this in Python. Again, for each test case, we call the function solve. We take the input of n, the input of array A and array C. Then we initialize our result or the answer to delete all elements in A as A0 multiplied by C0. That is the cost of deleting the very first element. Then from the further elements, we can check what is minimum, the current cost or the previous cost, whichever it is. We replace the current cost with that. And with this, we delete the current element in A. With this, finally we delete all the elements and get the cost that is minimum to delete all. And as we can see, I have got an EC in my Python implementation as well. So I hope you understood the problem, the approach, and how we can implement the solution in both C++ and Python. Have a very good day, and I'll see you in the next video.